Hello math friends. So today what's going to happen is you guys are going to watch this video lesson, and as we go through the video lesson, I want you for each problem to read the problem to yourself, pause the video, solve the problem. After the problem's been solved and you're ready to check if you've done it correctly, then you're going to unpause the video. So please don't just copy down what I'm doing. Also, I do not have my stylus at home, so I hope that you guys can read my bad non-stylus handwriting. And I do apologize if I make any mistakes in the video. I'm sure you guys will catch me on some. Just writing and talking and recording all at the same time. Sometimes I don't think it's clearly and I might make a mistake here or there. Sure, you guys will catch me on that though. So start with problem 1, pause it, solve it. When you're ready to go over it, press play. Alright, so I'm going to start talking about problem 1. So this is going to be a part-whole problem. It's not change in original because it does not ask us for a percent of change. Percent discount, percent increase. It's just asking us for new prices. There's 2 different sales, and you cannot add those sales together, the 25% and the 15%. You can't add them together and do a 40% sale. It doesn't work like that. That would actually cost the store more money to give you that much off. So you do both discounts / sales separately. You have to think about which one's happening first. The sale is happening first because that applies to everybody. So that 15% off is going to be the first thing that you deduct. Then you deal with the 25% off. It says the original price is $40, so that's going to match up with my 100. 100% of the cost is $40. 15% off means that you're paying 85%, and that's what we want to solve for X. We want to know how much you're paying. So when you solve that, doing it on my calculator real quick, we get $34, and that makes sense. Seems reasonable that a 15% discount off of $40 would be a total of $34 that needs to be paid. Now I need to apply the second discount. Let's see if I remember to copy it. Yes, I did copy my tic-tac-toe. Success. So it's actually going to be the exact same setup, except now the original price is $34 because we're working off of the discounted price. It says we have 25% off on our coupon. So we are paying 75% off, and we want to know how much that's going to be. So I'm going to solve that real quick on my calculator. And we get, this is now our final answer, 25.5, but you write it as $25.50. So that's the answer to number 1. Pause video, solve number 2, and then unpause. All right, hopefully you're ready to solve number 2 with me. We got a sale price that is 30% off, and when we actually pay that 30% off, we end up only paying $315, and we want to solve for the original price. So this is, again, part and whole. I forgot to put my units on the last problem, but it was money on that one and on this one. So this time, X is going to go with the 100 because we don't know what the original price is. We know that we are paying 30% off, which means we are paying for $70. Or not $70, 70%, sorry. And that 70% corresponds to a price of $315. So this setup is going to give me the original price. So for question A, I need to solve that real quick. So I'm doing $315 divided by 70 times 100, $450. And that seems reasonable. That if a discounted price was $315, the original price $450, seems reasonable. How much money did you save? You're just subtracting $450 minus $315. So $450 minus $315 is $135. That's what we saved. So that means that 30% of $450 must be $135 because that's the amount we saved. And what percent of the original price is the sale price? So this is that first tic-tac-toe of the original price is the sale price. And then I need a new color. What percent? So we need one more tic-tac-toe. So this is going to be part whole. We need a new color. It's getting kind of crowded in here. Part whole, and it's still money. So what percent? That tells me that X goes in the percent spot of the original price. So the original price is $4.50. Is the sale price? That's $3.15. So I'm going to solve that real quick. And by the way, if you're finding that you're not setting things up correctly and I'm showing you the correct setup, you can feel free to pause the video again and resolve it before I show you what the answer is. So I'm doing 100 divided by 450 times 315, and I get 70%. So the sale price is 70% of the new price. And do you know what? I'm just thinking now, probably didn't have to do a tic-tac-toe. It was a 30% discount. There was one discount only. So obviously you're paying 70% of it, but at least the tic-tac-toe confirmed that we did it correctly. So I'd be fine with you guys just doing subtraction on that one if you caught that. So problem 3, we have a baseball cap that is costing $24, but the store sells it for $30. Find the markup rate. This means that the store pays $24 to get it from the supplier. They up the price by $6 apparently because they want profit. So the markup rate is going to be the percent of that upgrade. So this is actually going to be a change original problem. Markup rate basically means percent increase. If you haven't paused the video yet, go ahead and pause it and then come back. Alright, so we're on money. The original price is $24. The change is $6. It's an increase of $6. X is going to tell us how much of 24 is 6. This is the amount that they are increasing the price. So I'm going to do 100 divided by 24 times 6, and I get 25%, which makes sense. 6, we know, is a fourth of 24. So that makes sense. That's a really bad rectangle. There we go. They increase the price by 25%. All right, on to the next page. So problem 4, go ahead, pause it, give it a try. This is a little confusing, so feel free to come back if you need my guidance. All right, so we haven't seen a problem like this yet, where we're doing like an equation with these percent problems. So we want an equation to determine the selling price on an item that's originally priced S dollars after a markdown of 15%. So markdown, first of all, is discount. So we're decreasing by 15%. So if we're discounting by 15%, we must be paying 85%. So what you could do to make this equation, one way to do this would be to start with problem A and start by doing a table with 5 possible pairs of solutions. So if we maybe make a table that's, I probably want to call it original price and sale price. And you're basically making up some values. We don't know what the original price is and we don't know what the sale price is. So you could really pick anything. So if you say that the original price is 100, the sale price is going to be 85. And if you don't know that off the top of your head, you could create a tic-tac-toe. The tic-tac-toe would be part, whole, money, and percent. Obviously, the 100 goes in that spot always. So now, in this case, it's a 15% markdown, 15% discount. So we're paying 85%. And we don't know what we're paying. And you basically just get to pick 5 values to put in that spot, and you solve for them and get the sale price. Because it's letting us just pick whatever 5 values we want. So if I start by putting 100 in there, and I solve that proportion, I'm going to get x equals 85. Excuse me. So that's the first row of my table. You could do another one. So you just pick any other value you want in there. So maybe you pick 200. So you solve that proportion, and I know it's going to end up being 85 times 2. So that's 170. So 200, 170. Literally, you're just picking any value you want to put in that gray square. You're making up prices and finding what the sale price would be. So I'll let you guys work out that rest of the table for yourself. So one way that you can make an equation for this is with COP. COP is y divided by x. So if I use the first row of my table, it's going to be 85 divided by 100, which is 0.85. So if I plug it into the equation y equals COP x, I get the equation y equals 0.85x. They want us to use S&P. I'm really not concerned about that, but I mean, it would be P equals 0.85S instead, but it's the same thing. Another way you could think about this is that you're always going to be multiplying 0.85, which is 85%, by the original price. That's confusing. The original price is S. I thought that'd be sales price, but it is original price. So that made me almost misspeak there. But that would be the equation. So you could go straight to that equation if you could figure that out. If not, you could use the table with COP and X to figure that out. I'm not going to go over 4B with you, but you are just plotting these points on the graph. You guys can do that. It asks you to interpret the point 0, 0, and 1R. They changed their variable from 1 to R, but basically you're just, it's, you know, it's those sentences that start with for every ... So for every $100 in original price, there is ... and then I'd say $85 in sale price. Something like that. You don't have to be too specific on that. I'm going to let you guys do the rest of it on your own. Hopefully that gives you a good idea of how you want to solve these problems. I really wanted to show you guys what 4 was asking because that was super confusing. But feel free to email me if you guys have any questions, and good luck on the rest of them.